Hello and welcome to my channel. My name is Mayank and this is the second video in the DevOps series, and in this video we'll be talking about source code management. I believe before diving into the real world of DevOps and how applications are handled in an enterprise setup, it doesn't hurt to understand few technologies and terminologies about source code management. Source code management is definitely the biggest elephant in the room, so let us dive in and try to address this elephant. Alright, let's go directly for the kill with the obvious question: what is source code management? Probably quite a lame question to put in the first slide, but essentially, source code management is nothing else but managing source code. Yeah, that is just the definition. But I'm not the guy who will give you long theories and lectures on what every topic means and what is the definition of things, but rather let us plunge into the world of source code management by understanding various important objects that we get to see when we talk about source code management or SCM. So, what are some important source code management objects? The first object that we can start with is a repository. The second most important object are branches. The third object of our interest would be a commit. I know these words would be too technical for you to understand in the first glance, but I will definitely do the explanation part later. But I'm just trying to draw a simple analogy between these objects. Going forward, the next important object for SCM could be a tag, and moving on, probably the most important SCM object that we would ever come across doing DevOps could be a merge. I don't know if that qualifies to be called an object, people will debate. But yeah, that is an important concept to get our heads around. And the list is never ending, so there are a lot of SCM objects. Trying to draw a simple analogy when we talk about these SCM objects, a repository can be thought of like a big box where our application code resides. Branches can be visualized as various compartments inside your big box so that all items in your big box are not jumbled up and then you go haywire trying to find a particular item and try to recall where it was. So, yeah, branches are compartments. The next important object is a commit. Now, commit is basically a snapshot of what items were there at a particular state of time in your compartment inside the repository. I know it is a little difficult to visualize, but I think if you try to picturize you setting up your wardrobe, placing all items neatly, and then taking a picture of it, just to remember what the arrangement was when you tried to clean up your wardrobe. So that's what a commit is. Now, every time the contents of your compartments or your repository keep on changing as new files are added, files are modified. So it is definitely helpful to mark your commits or to, to mark your arrangements or commits by special identifiers or labels, and that is what we call a tag. Tags are nothing but bookmarks to your commit which are identified as important and could be reused going forward. Now, merges are a little difficult to understand, but I would try to give another analogy here. Say, suppose you've got your compartments, and in one of the compartments you have a set of erasers, and in the second compartment you have a set of pencils. Now, when you do a merge from a set of erasers to a set of pencils, what you get is something like this. What I mean to say here is when you take items from a particular compartment or your branch and merge it with the other compartment or the other branch, what you get is a revised set of items that has an upgraded set of features and functions with qualities of both the first compartment and the second compartment. So that is the point I'm trying to make here. So let us talk about these objects in detail one by one. Now, the first object where we can start with doing SCM is a repository, or commonly called a repo. Now, repos are basically, as I told earlier, it's a box you create to store your code. As simple as that is. Your boxes can have items, which are files, and smaller boxes called folders inside them. That makes sense? If you feel like at any point of time you can put a lock onto your box so that strangers cannot see what is inside of your box. That definitely is helpful when you don't want other people messing around with your box or your repository. The next important thing is, as long as it is your box, you get to choose what can be put inside your box and nobody else. So that is definitely an inferred statement from point number 3, that as long as it is your box, you get to choose what can go inside the box. You can definitely share your box with your friends and also explore what's inside their boxes. given the liberty that they trust you and they give you the option to see what's inside their boxes. Creating a new repository on GitHub could look sometimes like this, where you get a form where you can fill in a bunch of details, and trying to make a correlation between these points, we can say the box is the repository. And now the lock that we talked about in point number 3 is the switch that we can enable or disable whether you want it to be a public or a private repository. Public repositories can be downloaded and looked into by anybody who is online, whereas private repositories will definitely need some kind of authentication to assure that the identity of the person who is trying to access is the same as the person who created the repository. The next point simply says you have ownership over your box and you decide what you put inside the box, and that could be seen in the picture as well. You get to choose whether you want to add readme files, or you want to add a license, or you want to add some other gitignore files into your repositories. Please don't worry about these technical words. It will definitely get a lot easier when we progress through this video. Now the third thing is you can share your box with your friends and explore what's inside other boxes. So that relates to the blue link that you see here, import a repository. So that is a feature that you can leverage to import repositories that are either somebody else's or your older repositories that can be imported into this new setup. Now let's talk about branches. As we already discussed, branches are compartments inside your boxes or repositories, and when you create a repo, you get the default compartment to start with. So that is called the main branch or the main compartment. You can definitely have n number of compartments in your repository as you please, and every compartment of your repository can have or cannot have similar things inside. That totally depends upon you. Also, when you feel like, you can choose objects from two different compartments and then create a new third compartment that would be inheriting from these previous two compartments, and that is the same thing we were trying to imply when we talked about a merge. Now let us see a visual representation of what branches look like on GitHub. So here you see an illustration which has got my repository, and I've got 3 plus 2 5 branches here. Each branches represent a particular feature. In my case, in your case, it might represent something else. These are 5 individual features that I try to work at the same time, and then I can have that kind of a separation or the kind of compartments inside my repository just to make things easier to access. Now let's talk about commits. Commits are basically records of what you have put inside your compartment the last time. When I said the example of taking the picture of your wardrobe when you tidy up your room, this is something that GitHub does. Whenever you put something into your compartment or your branch, GitHub tries to take a small snapshot of that and then tries to link it to a commit ID that becomes an identifier to go back to that configuration later. We already discussed this, that the record is maintained by a unique number called a commit ID, and using this record ID or the commit ID, we can go back in time to the last state of things and create a new state of things in your repository. Commits basically look like this on GitHub, and on the extreme right side what you see certain numbers. These are commit IDs which are represented as commit shas, that is a hash value, and these are definitely going to be unique for a particular repository, for a particular branch. That definitely makes sense. At any given point of time, you can choose to go back or go forward any commit ID so that your contents inside your wardrobe is what you expected. Now, since we got a little comfortable with commits, let us talk about tags. We already had this discussion before that commits are also snapshots to your code repo. Now, a special commit that you want to highlight could be saved with a bookmark, and this bookmark is nothing else but a tag. So it just helps you to highlight, okay, this is my commit, probably paint this in blue or paint this in red so that I can visualize going forward. If I want to come back, I can come back on this particular tag. That is what I'm trying to say. When we go to the next point later, this tag can be used as a reference point to deploy a recorded snapshot of your repo. Tags basically look like this, and this is a small example of a tag that I try to create. Now, when we are creating tags, we generally try to identify the point in time where my code was completely free of errors and it was running fine, and that commit ID I have specified to be identified as a release tag, so that when I want to release my application, I would definitely not go with the latest data which is inside my repository or the branch, but I would give them the tag ID so that they can always get the stable code or the clean code or the error-free code that resides on this particular tag. I know we are already progressing at a fast pace in understanding SCM objects, and it can get a little overwhelming when you encounter these keywords for the first time. But I can definitely assure you, you will see a hands-on and a detailed explanation when I do all these things on command line. So be assured. Now, the next important SCM object, or let us call SCM phenomenon, we can talk about are merges. I know I had given a very shitty example before when we talked about erasers and pencils. That is a stupid example to make, but I have come up with another example which can seem little less stupid. So probably let's try to understand mergers using this diagram. Say suppose you've got a packet of cheese in your first compartment and a packet of Maggi noodles in the second compartment. So when you merge the items in your cheese compartment with the items inside your Maggi noodles compartment, what you get is cheese Maggi. Now the important thing to observe here is that cheese Maggi has got properties of both cheese and Maggi, the two items that we tried to start with. I know this is a very lame example, but that is the best I can do. Alright, technically speaking, merges can be visualized something like this. Let's suppose you start with a clean fresh repository with a default branch main. From here, you try to create a new branch called the blue branch and you start working on your set of features. You try to add code, you try to make changes into files and folders, which are identified by three blue commits here. Once you're done with your code, you merge it to the main branch in the fourth green dot that you see. So the fourth green dot consists of the changes that you made on the files in the three blue dots earlier. And probably a different person who has access to your repository can create a new branch to work on his side of things, and then he is done just with one commit and he can then merge it back to the main branch. This way, more than one people can work on the same repository in harmony, and both of their changes can reside on the main branch after being successfully merged. Now, important thing here is every circle here represents a commit, so that I forgot to put before. That was the tough part that we already completed. That being said, let us look at some of the popular SCM tools out there in the market. We have got GitHub, which is one of the most popular tools. A lot of people in enterprise use GitHub as their choice of source code management tool. The next famous tool is GitLab, which is a newer tool in comparison and it's getting a lot of popularity. There's also something called Mercurial that people use. It is not that widely used, but people mostly in the enterprise use Mercurial for their source code management. And a groundbreaking SCM tool that is there in the market is AWS Code Commit. It works flawlessly and it is very easy to manage your code on AWS Code Commit. The next one is Apache Subversion. Subversion is pretty old source code management tool and very less people use it, but yeah, it qualifies for a source code management tool. And then we have Team Foundation Server, which is also now called Azure Repos. Now, definitely Azure Repos and TFS are two different things, but Azure Repos actually inherits from Team Foundation Server. So this is the Microsoft side of tools. When you want to work on the native to Windows environments, probably using TFS or Azure Repos can be a good choice. Then another famous tool out there in the market for SCM is Bitbucket. Now this is also relatively newer. Now let us shift our focus from core tools to certain concepts that would be important to understand when talking about SCM. And what follows is a very important question that is often crucial in interviews and understanding concepts. The question is, what is the difference between Git and GitHub? You would definitely agree this is a popular question and people get confused. So I would try to break the confusion for you. Now, Git is a software, GitHub is a repository. I don't know if that makes sense, but Git is a software that allows you to interact with a remote repository, which is stored on GitHub. Don't worry, we'll come back to this. That was a terrible attempt. I don't know how good that was an attempt to help you understand what is the difference between Git and GitHub, but don't worry, we'll come back to this. Now, if you have reached here, I would definitely want to create a Git tag here and mark this point as the point where that's all you need to know. I'm not joking. This is everything you need to know to start writing code. Let's get rolling. Or may I say, let's get coding. Alright, here we are. Time for the hands-on. And the first thing that I would do is try to head over to the website github.com. This is the popular source code management tool which uses Git to handle the repositories. And I'm going to click on sign in. Let me put in my username, and this is my username, and let me try to guess my password. I believe it's not wrong. So now you see I'm inside my homepage of GitHub. I'm sorry this looks a little messy, but on the extreme left hand side you see my repositories. So I've got a bunch of repositories on the left, and we will try to create a new repository to start with. So when you want to create a new repository, you've got two options here. Either you click on new button here, or you go to the extreme right top corner and see a plus icon and click on that, and you see the option of new repository. So let us use this option and try to create a new repository. Now this is the form that already we have seen in the illustration. Let us give it a repository name, and I would like to call it my awesome box. Great, so I have got my repository name. I can give a small description. This is a hands-on repo, and then I can choose if my repository is going to be public or private. Depending on the need of the hour, you can either choose to go with public or private. For now, I will go for public because I want to give access to people who would be watching this video so that they can clone and see the files inside that. Alright, the next check mark is whether I want to initialize the repository with a README or not. This is a 100% optional step. You can either go for it or don't go for it. But when you go for it, it will add a README file with the repository name and the description so that it can display the message of what this repository is all about. So I'm going to just click on add a README, and then I'll create repository. Perfect. This has created me a new repository with the name my awesome box, and this is the readme file that got added onto my repository, and this is how it looks in the first glance. Talking about branches, we already saw that branches would be compartments, and every repository gets initialized with a default compartment or a default branch called main branch. So I've got one main branch here, and there's nothing else. Next, we would like to clone this repository into our local environment so that we can work on it directly. You could also go in and use the UI controls on the graphical interface, but I am not a very big fan of GUI, so I will try to clone this repository onto my local and then go ahead with dealing with it. So the choice of IDE that I'm going to use is Visual Studio Code. I believe this is a popular IDE available in the market and it serves the purpose, so I'm going to go for it. So the first thing I would want is a terminal. So let me try to terminal, new terminal. I think this is already having Git installed. So if I go for checking the Git version, this has got Git version 2.39.1. So that's good. Now let's talk about how to clone this repository. For cloning the repository, you clean on the for cloning the repository, you just click on this code button and it gives you a URL to clone. There are options HTTP, SSH. There are options which is HTTPS, SSH, GitHub CLI, but I generally try to stick with HTTPS or SSH. And I will just use this link and head over to my Visual Studio Code and do a git clone URL. This will clone my repository, creating a folder onto my machine, and it has got my README file. This being a public repository, it is accessible to anybody who can want to clone it, and so that is basically how you clone your repository. Once you have cloned your repository, you see there's a new folder created with the name of the repository called My Awesome Box. And the first thing that we would want to do is go inside this directory. So I will do cd My Awesome Box, and now we are inside the repository. If you do ls, you will see the README file. So that's as simple as it gets. Now, if I want to view what branches are there on now, if I want to view what branches are there on my repository, I can just simply say git branch, and it will tell me a list of branches with with a star sign on the branch which is selected right now. So right now there's just one branch and it says a star sign before main, so that means this one is selected for now, and any changes I make to these files will directly be linked with the main branch. Now, the next task would be to create a new branch. So let us try to create a new branch. The command for creating a new branch is quite simple. Just do git branch, name of the new branch. Let me call my new branch, and then based on what the branch is going to be created. So this is going to be main. Why we are choosing main here is every time you create a new branch, it will actually take a reference from where it can copy the things and create the working directory. So you have to provide a reference point to the branch. So okay, take the contents from this particular branch and then create a new branch based on that. So if I hit enter, it's going to create a new branch for me. And then if I run git branch, I will see my new branch showing up here. The next problem here is the main branch is selected for the working copy and the new branch is not selected because I see asterisk on main and asterisk not on main. So I would want to switch my branch. So how do I switch branch? The command for that is again pretty straightforward. You use git checkout and then you put the branch name my new branch. So once you have done that, press enter and now it says it's switched to main branch. Just for confirmation, I'm going to clear the screen. I'm going to do git branch and it should show the asterisk on the new branch. So yeah, there you go. And now I have my awesome box folder with a readme file and I have got my new branch selected. Let us try to add some files here. So how I add files is generally by creating a folder or a file here using these two buttons. Let us try to create a file. I would like to call it sample.txt or txt, and I will also want to create a folder here saying main folder, or I can call it feature folder. All right. Inside of this feature folder, I'm going to create one more file with the name, say suppose feature.txt. Feature.txt. Many typos today, sorry. So now you see there is a bunch of new files been added here and you see sample.txt, feature.txt open. If I want, I can edit these files here on the go. So I can do probably sample. I can say this is a sample and then I save it. And on the feature, I can say this is a feature, save it, Control S for saving. Now you see there are a bunch of dots and letters appearing on this left hand side of the screen. So this U says that a new file has been updated, which is not exactly residing on the remote repository side. So if you see here, there is just the main branch. Even if I try to refresh the page, I see that there is just one branch here and there is no feature, no sample files here. So let's try to move it there. The process for moving the files there is called a git commit and a git push. So there's a combination of commands that you have to run in order to push these files so that these files are now reflecting, so that these files will be reflecting on the remote repository as well. So let us try to do git add, which will basically add everything into my working copy. So git add has added everything, and then I will do a git commit to take a snapshot of what has been added. So this will act as a restore point. So I'll just do git commit -m and put a small message. This is my first commit. This is my first commit. And display and putting a message is mandatory, so you got to put a message with what the changes are there. So I can just do a git commit and see it is saying there are two files changed, which has got two insertions. There's a feature folder. I have done a typo here, my bad. And then I've got a sample.txt. So what I will do is I will just try to now push this file to my report repository. So as you see, the indications have gone now. It says that the local working copy is currently in sync and all files have been added. In order to do a git push, I generally prefer to do a git push and it will give me the branch where I'm trying to push per my latest selection on the branch, and it will throw me a small command. So this is the command that I do. I can directly use this command and do a clear screen again and try to paste this command, and let's go. This will possibly ask me for an authentication because the public repositories can be accessed for everyone. Okay, I think I have ran few commands before, so it didn't ask me, but ideally it will ask me for an authentication for a username and a token. So that is how it works. Now, if you see, there's a bunch of information here saying there are some changes that have been done on the remote repository, and then there is my new branch, which is now on sync with my local new branch and the remote new branch, and branch my new branch is set to track for origin new branch. Let's go and head over to github.com and see if our files are reflected there. Let's do a refresh and let's see. Yes, we've got our new branch here. And if I go to my new branch, this is my new compartment that I created for my new folders. So you see feature folder and a sample.txt with the data inside. So what just happened here is I created a commit, which is an identifier for pushing the things. And the same commit ID is used for recording what changes were done in this particular chain set. So if you see, this is my first commit was the message that I gave, and this is the commit ID. If I go to the commit ID, I will see what changes were made, and it says there's a new file added. This is a feature and bunch of information down. Now, as you already saw that I made a typo mistake on this, let's try to correct this. Probably we will do one thing, we will clear the screen and we will try to make a change there. So what I'm going to do here is do a feature folder and I'll try to rename this. Let's try to rename this. So now I will call it feature. Oh, sorry, feature. This is the correct name and I will try to press enter. So now it has gotten the indications again because Git recognizes that a new file has been added and a new folder has been added. So this definitely does not sync up with the local copy. So I will need to do a git add again, git add, git commit, -m, updated or typo, mistake corrected. And then this was going to commit and you see one file changed. If I try to do clear and try to do a git push, this should give me the command and this should take me to push the files. So this is already set to use the default branch which I'm on and it has pushed now. Let us head back to GitHub, try to do a refresh, and here you see it's been corrected. And now if you go and see that the commit ID has changed, right? So commit ID has changed means what? Now there are 3 commits in total. This is the initial commit that we tried when we created the repository. Then there was the first commit when we pushed it the first time. And then we have the third commit where we corrected the typo mistake on CC82069. If you want to have a look at the difference, you can click on the commit ID. This will give you the difference of what it was. And it says feature folder feature text was changed to feature folder feature text. Just the typo mistake that got corrected. So that was it, how you interact with your GitHub repositories, and that is the essence of source code management for DevOps guys. And I think this is pretty much for somebody who's getting started with. There are a bunch of things that I would leave for the interest of time for this video, which is creating merge requests and creating tags. So probably that is going to come across in coming videos. But if you would like to see it soon, you can definitely drop me a comment and I will try to do a video on merge requests and pull merges and pull requests and things that are a little more complicated for the first video on SCM. So that was it, and we are done with the hands-on. See you in the presentation. That almost brings me to the end of this video. Let us have a look at the key takeaways that you have. The first takeaway is the answer to the question, what is source code management? I know that you know the answer to this. The next question is what are certain objects in SCM? We already discussed this and you're familiar about them. We also know how to work with multiple people on the same repo, the branching example that you saw or the merging example that you saw. And then we also know probably somewhat as what is Git and GitHub. We now know how to create GitHub repositories. We also know how to clone our remote repositories from github.com to local machines. We know how to add files to our repositories, and we also know how to work with branches. We also know how to commit code and push our code from local working copies to the remote repository sitting at github.com. That's an achievement. This definitely will set the stage for you when you try to work on SCM as a DevOps engineer. And definitely, when you go through the process of exploring SCM, you will learn more concepts, more technologies, but this would be the foundation that you have now. And with this strong and solid foundation for source code management, you can definitely go outside and explore any SCM tool that you want, which is available in the market. I'm not kidding. This brings me to the end slide of the video. I would like to take a moment to thank you. The first video received some views. I was not expecting them, but I definitely received some views and I'm all teary-eyed. So thank you for everybody who has watched the video, and I can promise you there are more videos coming in and I'm trying to balance everything. Just hang tight and I'll see you in the next one. Peace.